All right, this video is just a quick reminder for probably pre-calc level students, those who've already learned these properties of logarithms before, of what the properties of logarithms are. Remember, we have some properties that basically say the logarithm of two multiples, right, of a multiple of two things multiplied, log of x times y can be rewritten as two separate logarithms. Note the same type of log. I had a common log on the left, so two different common logs here. This could also be done with log base 2 or 3 or whatever that might be. Then both of these logarithms, right, would have the same base that they started from. But again, we could separate log of things multiplied into things added. We can separate division into subtraction of two separate logarithms. Or if there's an exponent inside, we can pull that number out in front and call it multiplied by the log of x. Again, if you want some proofs of those, there's proofs all over the internet, so feel free to look up the proof of why that stuff works. What we really want to do is use it to expand, right? We want to expand logarithms because sometimes that's a very helpful thing when we go to calculate logarithms. So how would we relate over here log base 5 of 18 to sort of its expanded form, 2 times the log base 5 of 3 plus log base 5 of 2? Well, the first thing I would think about is the log base 5 of 18, well, it's still going to be log base 5, but I could rewrite 18 as a mess of sort of its prime factorization. So 18 again would be a 9 times a 2. And again, 9 could be separated into 3 times 3 times 2. So basically this is 3 squared times 2 here, which means I can kind of separate that out. Again, I have two things multiplied in there. So the log base 5 of 3 squared plus the log base 5 of 2, right? And then remember that exponent rule. If there's an exponent inside a logarithm, we can move it down in front, which is basically where we get this 2 log base 5 of 3 plus log base 5 of 2. So again, that's how we can expand those things out. So let's try a couple more here. Now, you don't necessarily always have to expand them completely out, but it does help to simplify sometimes. So again, if I'm looking at this log of 100 over 7, the first thing I'm going to do is separate it into the log of 100 minus the log of 7. Now, log of 7 doesn't do me a whole lot of good, but I do know that 100 is 100 squared, or sorry, 10 squared. So I could say the log of 10 squared minus log of 7. And since these are common logs, they're log base 10s, well, log base 10 of 10 cancels away. Probably my best statement here is that log base 10 of 10 squared is really just 2, and I would subtract off whatever decimal value that log of 7 would be. But that's as expanded, right, without rounding off, expanded as we can get. I would do the same thing down here with log base 2 of the stuff we have going on here. Log base 2 of, we've got 4, which I'm just going to immediately call 2 squared, if you don't mind, plus, right, we were multiplied inside of our logarithm, we can make it into addition of log of x to the 6th, and again added on to the log of y. In the end, I'm going to go ahead and cancel that first one, right? Log base 2 of 2 makes it just a 2, plus, I'm going to pull that exponent on the next one, so this becomes 6 log of x. And again, the log of y, I really can't do anything about, but there's our expanded form, right? Inside of our logarithms, when we're done, we've got just a single x here and a single y there, right? We want to separate it out into a separate logarithms added or subtracted together, possibly products, right, with that 6 in front, but with single, right, items inside, single terms inside, just x or just y there. Last problem here, same idea. Again, the first thing I see is that division, so I'm going to separate that out. Log of the top minus the logarithm of the bottom. Now notice that's a square root, and when I think about logarithms, I always like to think about exponents when it comes to roots, which means I can make that a 1/2 exponent. So now I have to make a decision. Well, should I pull that down in front, which I think I will. So I'm going to call this the log of. Now you might be tempted to say, oh, hey, it's subtraction. Well, remember, we have rules for multiplying inside or division inside or exponents inside of logarithms. We don't have a way to separate subtraction. It's already subtraction, right? So where division made subtraction, subtraction doesn't work the other way around. So we just are stuck with that x minus 2 inside that logarithm. But again, I can say minus 1/2 the logarithm of xy. And if I want to separate a little bit more, again, the log of x minus 2 minus, I can make that logarithm into two things added, but now remember, we've got this subtraction in front. So what I would probably want to say is minus 1/2 the log of x. And because I'm going to take that negative half and distribute it kind of, normally I'd say plus, but I'm going to say minus 1/2 the log of y. Again, that negative half essentially gets distributed across what would have been an addition problem, right? But now both parts are multiplied by a negative half. Let's do one more quick example here, a couple quick examples. Here's kind of an old-fashioned way of doing this. We can basically take numbers, even though I don't know what log base b is, I don't know what b is in this problem. If I know a couple of values, right, I can actually find these numbers. So log base b of 6 could be log base b of 2 times 3, which is the log base b of 2 plus log base b of 3, which means now I can substitute log base b of 2 according to my directions is equal to 0.693. And again, according to my directions, log base b of 3 is 1.099. Well, now I can add those up, 1 point. Now I'm going to have to do a little bit of math in my head here, or I can take advantage of my calculator real quick. But again, that's 1.6 would be 1.78, 1.792, I do believe. Yeah, you might want to check me on the calculator on that one. But again, we can find, even though we didn't know what the base was, we can find that value. Similarly, again, log base b of 3 minus log base b of 2. So again, now I'm going to take my 1.099 minus my 0.693. And again, we can just calculate those decimals. Subtraction, much easier to do, even in our heads, than calculating logarithms, right? So again, you can go ahead and find. I'm going to leave that one to you. And I'm going to move along just a little quicker here. Last one on the right here. Again, we've got division, so log base b of 1 minus, and again, because it's multiplied on the bottom, I'm going to jump a step, log base b of 2 plus, now notice I used parentheses, so I'm good with that entire denominator, right? Well, maybe I should write this out. Again, we've got that going on there. Let's go ahead and write this out. Log base b of 1 minus, again, log base b of 2. Because it would be addition, if I don't distribute the negative, I can write that. But again, I'm going to be log base b. That square root I'm going to make into a 1/2 exponent. And now let's do some canceling. Log base b of 1, remember log of 1 is always equal to 0. Log base b of b over here on the right is going to cancel to a 1/2. So really I'm subtracting log base b of 2, which remember we know the value of, plus 1/2. Or basically we're going to get negative 1.193 for an answer. Again, I'm going to leave the middle one to you. That's just a little subtraction, but I hope that helps you expanding logarithms. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.